what the work package 6 can bring to this decision tools question. So I will speak for the task 1, which is on the herd modeling, and I will only speak about the dairy part, and Daniel will speak for the beef part. So yeah, quickly, I just copy paste what we are supposed to do in task 1 in work package 6 about predicting the lifetime trajectories of beef and dairy cattle. And basically, the question we want to address is how can we predict the performance of various genotypes in the herd, and depending on the local environment, given that the local environment is about both the feed resource on the farm, but also on the farmer's management. And finally, if we want to look at genotypes performance within the herd, it's because we want to see what are the long-term consequences of breeding and selection strategies. And as I think Morten and Donna has presented, those breeding and selection strategy may be decided within the breeding sector, but in the end, it's within the herd and by the farmer that those strategies are really implemented. And we also want to see, as we are developing predicting modeling tool, we also want to see how the genotypes we may select today will perform in the future conditions. So very quickly, the approach in our task is to move from the animal to the herd. So we have a dynamic dairy cow model that is simulating traits through life. So it's really like the birth from the culling or the death of the cow. And this model is as a nutritional approach, so we have all the response to the diets, but the key point in this model is that the drivers of the trajectory you can see above the cow, it's really based on resource acquisition, so dry matter intake basically, and allocation of energy among different biological functions to account for trade-offs among those functions. That's a key point in the development of this model. And therefore, something else to keep in mind is that the number of lactation of a cow or its longevity is the result of a simulation. It's not something that we decide before. We just give the cow a potential of acquisition, an allocation strategy, an environment, and then the simulation generated the traits. We move on from this animal level to the herd level based on an individual based approach, which is that every cow in the herd corresponds to a dynamic model. So it's like really a virtual herd. And we are using 4 parameters related to resource acquisition and allocation as scaling parameters to represent different cows and different genotypes in the herd. Then we should give the herd a local environment. So far it's dynamics of feed resource availability, dry matter offer through time on a daily time step, and energy content of the feed offer. And we also have management strategy. So far it's reproduction and culling and replacement. And once we once the simulation is done, we get a diversity of lifetime trajectory within the herd, and we also get the technical performance of the herd. And we are working currently with work package 5, so Morten and colleagues, to refine the way we will represent breeding and selection within the herd. We also want to have an evolving herd, like the parameter related to acquisition and allocation of resource are transmitted through generation, and this way we can really see where the individual within the herd are going. So I try to illustrate how we introduce the genetics within our herd, because it's so far what I said is just about phenotypic level. So we considered that to set the population or the herd of cows, we need a sire population to introduce genetic variation. So basically, we use assumption on a pedigree structure, on heritability and correlation to create breeding value for sires based on the 4 parameters that we use to create different cows. So when the cows get values for acquisition and allocation parameters, part of this value is based on the breeding values of the sire. So then we can simulate a different scenario with feed resource and management rules. So we get the simulated traits for this particular environment. And what is interesting with simulation is that you can change the scenario. So you can simulate another environment. And for instance, you can compare, just an illustration, 2 metrics related to efficiency. One is the ratio both are ratio between energy for milk and energy intake from the environment. One is computed at the scale of the second lactation, and the other one is computed at the lifetime level of all the cows. And here you just see 4 very contrasted scenarios of feed resource dynamic, basically from a very good environment until a very low environment. And we can see that for the phenotypes, we don't see big difference at the scale of the second lactation, but then if we are looking at the lifetime efficiency, we can see that the environments have strong effects. And then, as we have introduced genetic variation in our cow population, we are able to compute genetic parameters, and this way, it's our approach to go toward evaluating G by E in our population of cows. So I skipped that it just to show some variance covariance metrics for some traits, but it's basically just what I've said. And yes, we are, so I tried to answer the comment of my work package leader to say what are the connections with the different tools developed within GenTORE. We have strong interaction with Morten, Christian, Margot, and Jörn for developing all the breeding and let's say the genetic aspect we want to introduce in our model. And I think it gives us more insights from what happened in the breeding sector. We can also, I think, collaborate more with the work package 3 because we do have biological model that needs to be more based on real trajectories. So we had already started this work with the calibration. Freddy Ramirez, our postdoc, is working on this calibration part, but this is a connection that we can think about. And of course, within the work package 6, we are working on having more socioeconomics outputs. And now we need to move a little bit more closer to the farm because we are still at the herd level and we miss some very important part of the farm, especially the feed resource that is produced on the farm. So far we only have feed resource availability that is basically a text file that is eaten by the cows, and we need to have a more consistent feeding plan with on-farm feed and purchased feed. And to link this on-farm feed with land use on the farm, basically, let's say crop and forage, which will enable us to also introduce dynamics for yield and quality of those crops and forages produced on farm. To give some consistency with this feed resource module and the management strategies on farm, we worked with FADN data from work package 1 to select type of production system. So basically it's going to be Holstein cows in West Atlantic climatic zone and Montbéliard in Central Mountain climatic zone. And to make a step further to specify the farms, we are working on the case study from French Livestock Institute. And this is important because it will give the farm simulation a concrete context, like what is the climate, what is the soil for this particular area, what could be the price for this. And this is important because we want to test some climate change impact scenarios, and how the yield for the crops and forage will change is based on this concrete context of soil and climate. And as a first step, we will probably use prediction of climate change impact from other projects. That is the part where Anne-Isabelle and Philippe from INRAE are working on. And these concrete contents can also help to connect with other colleagues. For example, Lotta is developing social life cycle analysis, and it's important to have euros and social aspect behind our technical outputs from the simulation. So what it is for, I think the tool we develop is not a tool to represent one particular farm. It's much more a tool to compare scenarios and identify pathways, trends of change, and understanding the relative role of drivers in determining herd performance. And for instance, we know that in the future, ruminant should eat more grass for the question of feed food competition. So we may have a scenario of increasing the proportion of grasslands in farm surface. Drought can happen every 2 years, let's say, because of the climate change. So there is a decrease in the grass yield, and farmers can adapt or not by buying purchased feedstuff. And this is the kind of option we can study, and we can answer questions like, what will be the herd performance given those future conditions? If the bulls used to breed the cows are based on a scheme with a breeding goal and highlighting milk production or body condition score, and for instance, what if the culling rules in the herd are very strict on reproductive failure because it's a seasonal calving? I think this is the type of question we will try to address in work package 6.